Okay, good morning. So, I want to continue a little bit the lesson that we started yesterday because that's important. I want to give you more exercises to solve. But remember, if you remember last lesson, I gave you two pairs of brackets at most, even though some of them were quite lengthy to calculate and finalize. But I gave you only two pairs of brackets, and I asked you to multiply them. But in principle, this can be extended to more than two pair of brackets. Yes, exactly like numbers. I can give you multiply two numbers, like 2 times 3, it becomes 6. But I can ask you multiply 2 times 3 times 7, for example. I can ask you multiply 2 by 3 by 7 by 8. So you can, in principle, multiply any number of numbers by each other. Yes. So here, that's also the same thing with algebraic expressions, but of course in algebraic expression it becomes immediately very messy if I give you a lot of pairs of brackets. Yes, but that is inevitable. That's the only way that we can do that. And of course, also I was just trying to see if I can find the correct command in Geogebra to give you that, because usually, especially when you go to higher mathematics, these are actually boring for you, so then you want to do something here to be able to solve the real problem, which is harder. Okay, it's always good to practice with GeoGebra as well. Okay, but before that, let me just refresh your memory by giving you an example for multiplying a pair of brackets, and then I ask you, for example, you can also participate in this lesson with me, and then you can share your ideas and opinions about this. So let me just immediately start. And this is one of those long lessons. So whenever you are, I think, so we go for 45 minutes, and then we will have a break for 10 minutes, and then we continue. Okay, is that good for you?
Yes.
Okay. So please remind me from now if I don't remember, because usually I get excited and I forget, but 45 minutes from now, okay? So, if you remember, we started this lesson, and I want to give you an example here. Let me start from this example. I want you to expand. So these are the words. I might use expand, I might use do the multiplication, or one of these, or I can just say simplify. Okay? So I want you to, of course, little by little, I want to be faster and faster in these calculations, yes? X minus 3x squared minus 3x plus 9, I want to multiply. So what I do first, let me just review the lesson, if in case some of you haven't quite understand what's going on. So I have two pairs of brackets and I want to multiply them. If someone asks you what is the underlying rule for this, what was that? Which rule is very important here? We have three rules: commutativity, associativity, and distributivity. Yes? So distributive law is actually very important in multiplying two expressions like that. So what you do, you need to think the first pair of brackets as two terms. One term is x, the other term is -3. And here I have 1, 2, and 3 terms. So what you need to do, you need to multiply every term from the first pair of brackets into all the terms in the second bracket. And you have to do it patiently. And then at the end, you have to simplify, even if it is not mentioned in the problem itself. Okay? So what we are doing it, so I take this x multiplied by x squared. If you understand it, I really want you to do most part of the job in your head. It's better. Okay, so x times x squared is x cubed. X times minus 3x is minus 3x squared. X times 9 is 9x. Is there any particular question so far? Is that understandable for everyone? Okay, good. So you see, I started from x. I didn't do things randomly. I just took x, multiplied by all the terms. When it is finished, I go back and switch from x to -3, and I do the same thing. So -3 times x squared is minus 3x squared. -3 times -3x is positive 9x. And finally, -3 times 9 is -27. And I will not stop at this stage because I have to simplify even though it's not mentioned. Simplify means that I need to detect the similar ones. The similar ones means the ones that have identical letter parts. So I need to group them in one group. X to the power of 3 is alone. You see, there are no other terms which the letter part x to the power of 3. So that's just alone. But here I have this one and this one similar. And I have this one and that one similar. Be careful, even though I am multiplying two pairs of brackets, at this stage I am not multiplying anymore. I am adding or subtracting. Multiplication is finished at this stage. Okay, so x to the power of 3 is alone, so I just copy and paste that. And then I go here, minus 3x squared, minus 3x squared. Let me just describe it once more. So you are facing minus 3x squared, minus 3x squared. Don't get confused. Here is not multiplication anymore. What is the answer? So what you can do, you can take x squared out, and then you have minus 3 minus 3. But if I ask you what is minus 3 minus 3, the answer is minus 6, so it becomes minus 6x squared. I really don't want you to do this, but I want you to understand what is going on. So whenever you see this, please just simply write 6x squared, unless the numbers are big or in fraction form so that you need a scratch paper. Otherwise, just try to do it in your head. And then you go to the next pair, 9x. I have another 9x added to that, so it becomes 18x, and then minus 27. This is the answer that I expect you to write for me in order to be able to achieve all the points in that example. Yes? Is that clear? Okay. But now, yes?
Or no.
Okay, so let me point you something. That's also good to make sure that you haven't ignored some of the terms. Before simplification, how many terms you expect? It's easy. How many terms are involved in this pair of brackets? 2. How many are involved here? 3. So 2 times 3 is 6. So it means that before this stage of simplification, you should have 6 terms in front of your eyes. If you do not have it, or you have more, it means that you have done some mistakes. Let us count. Now, 1, 2, 3, 4, 5, 6. But before simplification, you see that after simplification, I have 1, 2, 3, only 4 terms. So that rule only applies before the stage of simplification. So that's a good rule of thumb to check that if you have ignored something accidentally. Yes? But the idea is this one. I'm completely sure that you understand everything. But even myself sometimes, if they are actually, a lot of these might be making some mistakes. Yes, but you need to practice. I want you to practice so that you can do it quickly without that much energy being used. This is important, yes? Because these are just become very elementary things. We have to be able to do them very quickly to be able to study more advanced stuff. Okay, so let me, of course it might be a little bit boring, but let me just, this one as well. So a squared plus b, and then let me multiply it by another pair of brackets, which is c minus b plus d, and then minus a squared. Yes, that's good. Okay, so let me multiply these two pairs of brackets. So, how many terms are involved here? 2. One of them is called a squared, the other one is b. How many terms are involved here? 4, c minus b plus d and minus a squared. I have to take each one of them and multiply it by all of them. So here I take a squared and I multiply it by this one, that one, this one, and that one. So this becomes a squared c minus a squared b, and I really recommend you to try to write this with legible handwriting as much as you can, neatly and clearly, because it might happen that when you want to solve it, you write it in a messy way, you get confused for the next line and you cannot detect. This is important. So a squared c minus a squared b plus a squared d. Okay, so if you are with me, what is the next one? Are you with me or not? What's the next one? Yes, minus a to the 4. Thank you very much. And then everything is finished with respect to a squared. Then I switch to the next term and do the same process. So b, positive b times positive c. Why it's positive? Because nothing is written behind that. So it becomes positive bc, and then I will have minus b squared. Please ask questions if you really don't understand anything. So b times d, and then I have b minus ba squared. Okay. Can you detect any similar terms here? Yes, Simon?
A to the 2, b, and b, a to the 2.
Yes, they are similar because you might say that they are not completely identical. I agree with you. This is not identical with that because you can see the difference, but the difference here is not important. Why? Because we know that the product, the multiplication, is also commutative. So there is no difference between minus a squared b and minus ba squared. Yes, they are exactly the same thing. So I can take them similar. But can you see any other similar terms involved? So here you have to be careful. Might be you just accidentally miss something. But I don't think we have other similar terms. Do you agree with me? So then it is up to you in which order you want to write them. So for example, I would write a squared c first. And then I need to do something with these two. So can you tell me what should I write here? I want to make sure that you really understand what's going on. So just tell me what I want to write for these two here. Yes?
Positive a to the power of 4, b to the power of 2.
Be careful. That is exactly coming from my teaching experience. You remember, I just mentioned that don't forget that at this stage you are not multiplying anymore. Is that clear? So you multiplied them. So you multiplied this term with that term. Be careful. Let me repeat this. Whenever you, by the way, please trust me, I have been teaching mathematics for your age nearly 30 years now, so I know what are the common mistakes. When I emphasize something, I really mean that. Because you see, if I multiply this by this process on this line is multiplication. But multiplication is finished. From here to here is addition or subtraction. So don't get confused. The first stage is multiplication. The second stage has nothing to do with multiplication. It's just addition or subtraction normally. So what you now, can you fix it now?
It's minus a squared minus.
So let me write it again. If you really want to think about this problem, you need to think in this way. If I give you minus x and I give you another minus x, what is your answer to this? Just simply answer this one. You yourself.
Minus 2.
Minus 2x. So why didn't you multiply them? If I want you to multiply them, I have to write it in this way. Then the answer becomes positive x squared. If you think that you will forget it later, please write it down in your notebook and say that's important. Okay, so this is the difference between them, yes? Now, at this stage, let me write this one, minus a squared b. And if you don't mind, I told you that a squared b and b squared a are the same, so let me interchange them in my head. So it becomes again a squared b. What is the sign? This one. Now I ask you, this pattern, is it comparable to the second row or to the first row? It is the first row, so it is not a multiplication. I do not have any other things in my box to teach you this. You need to understand it yourself. Yes? So minus a squared b minus a squared b, what can I write in front then?
2a to the power.
Just say everything.
What?
Say everything again.
Everything again.
Yeah, yes.
2.
Not 2.
No, a
Yeah.
to the power.
No, minus.
Minus.
Minus 2.
Okay,
Minus 2
Oh, sorry.
a squared b. Agree?
Yeah.
So I hope that you can see that this is this pattern, not that pattern. So let me just repeat, it's important. Even though I am asking you to multiply, multiplication is finished in this stage. Simplification is no longer multiplication. It's addition or subtraction. Everyone understands that? Okay, good. Now, so at the end, I have to write minus 2a squared b. And then what can I do? So I copied and pasted this one. I did something with these two. The rest of the terms are non-similar. So I have to copy paste them. That's it. So that's your term. Let us check. How many terms were involved here? 2. How many terms were involved here? 4. Before simplification, how many terms do I expect? 8. Let us count. 1, 2, 3, 4, 5, 6, 7, 8. So that's a good rule of thumb to make sure that probably you are not ignoring or suppressing something. Okay. But now, let me, I don't know, who went for the nurse? Someone actually, who? Rasmus. Okay, so let me do this thing. I will write something on the board, you do it for me, and then when Rasmus is back, I ask you no one leave for 5 minutes and then you can leave, okay? Because I want to teach you how to multiply 3 frame brackets there. So let me just write something for you here. So let me write this one. X plus y minus z multiplied by x minus z. Okay, just do it for me. Okay, so Rasmus is back. So let me just teach you this one, and then the next person can go. Okay, so just wait, please. Don't solve this one. Now I want to teach you how to multiply 3. For example, forget about this momentarily. Let us concentrate on this problem. Let me make it very, very simple for the time being, okay? So let me take it very simple. So here I want to multiply three algebraic expressions. One of them is very simple, x. Please stop solving the previous one. Just focus here, and then the next person can go to the nurse. Okay, here, if I want to multiply these 3 numbers exactly like this, 2 times 3 times 4. If I ask you to multiply these 3 numbers, one strategy is to multiply 2 by 3, get the answer in your head, 6, and then multiply 6 by 4, yes? So then it becomes how much? 24. Or, of course, if you want to, you can multiply the first one by the last one. It becomes 8, and you multiply it by 3, it becomes again 24. Or you can multiply 3 by 4, 12, multiplied by 2, 24. It doesn't matter, yes? But be careful. There is a very big difference. Am I allowed to multiply 2 here and there? You might find it silly, but I have seen later you might get confused. You are not allowed to multiply 2 by 3 and by 4. If 2 is being multiplied by 3 plus 4, then if you want to, you can do this. So be careful. This is not correct. Okay? So here, the same story. How many numbers are involved? Let me underline them. 3 numbers are involved here. So if I ask you to multiply them, the rule is exactly as before. You take one of them, multiply it by the second one. Do not touch the third one momentarily. When you find the product, and then you multiply that product by the second one, by the third one, and then continue. So if I want to solve this problem, okay, I want you to tell me what to do. What I can do, I will take the first number and multiply it by the second number. But you already know how to solve this problem. Here you have to multiply here and there. I really want you to understand so that you don't get confused. You see, here I want you to see that this is possible because that is a product, that's multiplication, that's addition. So what I do, I take this one and multiply it by x. So let me write it in this way. X multiplied by x is x squared. X multiplied by plus 1 is plus x. And then when you put equality, you shouldn't be in a hurry. You need to respect the meaning of equality. So it means that I have to copy and paste the part that I am not touching. So let me just wait. Understandable for everyone this stage? Okay, and then you are facing the previous problem. If you have done your homework to this stage, you can immediately solve that, because forget about this one now. Assume that the teacher has given you this problem from the beginning. That's a simple problem now. That how many pairs of brackets are involved? 2 of them, so I will take the previous lesson. So what should I do? I will take this one multiplied by this and this. It becomes how? It becomes x to the 3 plus 2x squared. This is finished now. I go to the next one, multiply this here and there. So it becomes plus x squared and plus 2x. Is it finished now? No, because I realize immediately that these two terms are similar. So let me just review something. Do you remember what was the meaning of a coefficient? Can you tell me just this term, what is the coefficient of this term? Let me ask you this. What is the coefficient of this term?
2.
It's plus 2, okay? But of course 2 is the same. What is the coefficient here then?
1.
1. Because whenever no number is written there, because if I have just x, if I ask you what is the coefficient of x, you would say that I can write it as 1 times x. So the coefficient is 1. So whenever you do not see, by the way, what is the coefficient of minus x? Minus 1. So these are the things that I want you to know. These terminologies you need to know. So what I can write, x to the power of 3 is alone. So I just copy and paste it. But the other ones are actually similar. So again, 2x to the 4 is the correct answer, or 3x squared is the correct answer. Because at this stage, multiplication is finished, we are doing addition. So this becomes 3x squared. Thank you. And then what is left for me is just 2x. So that would be the final answer to the expansion of this. Clear? Okay, good. Now let me make it a little bit harder. So let me have x plus 1, x plus 2, and x plus 3. Yes, we have questions? Yes?
And it's kind of related, but what was the name for the part that wasn't the coefficient in a term?
Constant term.
No,
So
no,
here
no,
this...
No, but well, the thing that when you just write 2x, yeah, then it's a variable, but when you write 3, for example, 3x squared,
Yes?
what is the name of x squared?
X squared?
Or
No,
what
no,
should you
x
call, is there a name?
No, I wouldn't say there is a name for this.
Okay, so there is a name like coefficient for 2.
It's an
Yes.
algebraic.
Yeah.
Yeah, that one is actually...
No.
So these kind of algebraic expressions are called polynomials.
Polynomial.
Okay. There I will talk about them later. But each one of them is called a term.
Yeah.
Is that what you mean?
My question was, what is the x squared called?
No,
That's part of the term.
X
or-
squared is not... Yes, this x
or
squared
b
is one
squared.
term. This 2x squared is another term.
Yes, but what is the x squared part of the 2x squared?
No, I would
called?
say literal part.
Okay.
Yeah, I wouldn't say
There
there's
isn't a nice name like.
No,
there's
at least
coefficient.
I am not aware of.
Okay.
Yes.
No, that sucks.
Okay, so then we want to continue here. So again, what should I do? I have 3. Can I say I have 3 numbers involved? That's not a good way of saying. I have 3 expressions involved. But algebraic expressions at the end of the day are numbers. Oh, sorry. No, nothing? I'll just continue? Okay. Okay. So here you want to start multiplying these 3 numbers again. So they are, I'm just telling you, the correct name for this is actually an algebraic expression. I'm trying to multiply 3 algebraic expressions because I don't know exactly the value for x. This is why we call it a variable in algebra. But if I ask you what is this at the end, you would say that this at the end represents a number written in a little bit fancy way. Okay? So now if you want to multiply them, every rule that you have learned for multiplication is applicable here. All those three important rules. Okay? So I multiply this by that according to what we learned for multiplying two pairs of brackets. Yes? So it means that when I put equality, I decide to multiply this one by this one. It means that I will not touch this. So let me just copy and paste this one that I don't need for the time being and concentrate on solving a simpler problem, multiplying two pairs of brackets. So then what should I do? I multiply this by that. It becomes what? X times x is x squared. And then x times 2 is plus 2x. And then I have 1, which is very simple. 1 times x is itself, 1x. 1 times 2 is just 2. Okay? And then I close the pair of brackets. Now if I ask you what I have done, you would tell me that you just multiplied these two and you know my strategy. My strategy is to find this product, which I already did, and then multiply it by the third number. Okay? If you start multiplication right away, that's working, of course, but I want you to develop this new habit in your mind. For human brain, it's easier to simplify and then proceed than multiplying and then simplifying. For example, if I give you this number, 65, and I ask you to multiply it by 65, 59, of course, you can multiply this number by that number, multiply this number by that number, and then divide them. But if you can simplify this one with that one and this one with this one, you can just under 1 second answer the answer is 1. So simplification and then continue is much better. In simple algebra, you will not face a very big problem, but if you get this habit in your mind, you will continue this, then you will face bigger and bigger problems when we go to higher courses. Okay, so what I'm saying is that if I were you, I will not continue multiplication right away because I realize that I can simplify this a little bit more. So here, I see that this one and that one are similar. By the way, you need to train your brain in this way. When I am doing something here, I have trained my brain ignore the other parts. Because otherwise you will get just distraction from other parts. So you try to learn this, that when you are focusing on something, try to ignore the other parts because otherwise you will be probably distracted by those. So what does it mean? It means that I can copy and paste the part that I really don't need to do anything with it right now and just concentrate here. Okay, now can you tell me what is the better version of this that I want to write here? Yes, please.
X squared plus 3x plus 2.
Yes, and that's very good because even though I have been multiplying here, but multiplication is finished at this stage, as I mentioned before, and I am actually adding things. Okay? And now I am ready to do another multiplication. Okay? So what can I do again? So I continue. I take this term, multiply it here and there. When it is finished, I take this term, do the same thing. When it is finished, I take this term and do the same thing. Yes? So let us just do that. X squared times x is x cubed. X squared times 3 is 3x squared. Finished. I go back to this one. 3x times x is 3x squared. By the way, I am doing it quickly. Do you have any problems doing this? If you have any problems, do you understand everything? Yes or no? That is on you to ask me questions, okay? So, where was I? I multiplied these three and then I reached. So I multiplied this by that, I multiplied this by this, these are the terms, and then I moved here, multiply this is this one, and then I multiply this 3x by that 3, it becomes positive 9x. This is also finished, I go to the other one, plus 2 plus times x is plus 2x, and then plus 2 times plus 3 is plus 6. But is this problem, do you think, finalized now? In this form, no, because I have similar terms involved, yes? So what can I do? I can just detect the similar terms, and that is a very simple pattern to see. They are similar, why? Because the literal parts are identical. and these two are similar. So this means that, is multiplication finished at this stage? The answer is yes. So what is left for me is addition or subtraction. But of course, no subtraction is involved in this case. So I copy and paste the x to the power of 3 term, which is alone. And then I have 3x squared plus 3x squared. The answer is 6x squared. Okay? And then I have 9x plus 2x. What is that? Everyone, please. 11x squared, yes? No. 11x. And then I have 6 left. So that would be the package, that would be the final answer of multiplying these 3 polynomials. Of course, if the number of terms are actually increasing, then this becomes more tedious. And probably if you are completely comfortable with this calculation, then it becomes immediately boring for you, because there is no surprises there, yes, because you just multiply things. Okay, so for example, let me tell you something else here. If I wanted to multiply just here, it is working, but how many terms are involved here? 4. How many terms are involved here? 2. 4 times 2 becomes 8 terms. But when I simplify, how many terms are involved? 3. How many terms are involved? 2. So when I multiply them, I get only 6 terms. So it means that if I do this simplification, instead of dealing with 8 terms, I will deal with 6 terms. But of course, there is not big difference for these simple problems. But I'm trying to tell you that you need to change the way that you think about the problems. Okay? Do not ignore these simple differences. Because these things will be accumulated in a hard problem and make it actually formidable for you. Yeah, we have still time, yes. No, I just want to give you some examples. By the way, let me finalize this lesson by putting a power on one of them. So what do you think would be this? So that's also the new lesson, moral lesson. My question for you is that, let me start with a very simple one. Okay, so I would write x plus 1 to the power of 2. I want you to expand this. By the way, another way of saying expand means write the expression without any pairs of brackets left. So here I start with this expression with 2 pairs of brackets, but I ended up here with no brackets at all. So another way is that write this expression without any pairs of brackets. Or I can say expand this expression. This is a really common mistake, that people think that this becomes x squared plus 1. And if you don't mind, let me make it 3, because 1 is a little bit exceptional. Many people say the answer to this is x squared plus 9. Okay, I want you to write this down if you are actually doubtful and cross it over, because that's the wrong version. Okay, so be careful, you are not allowed, because if you are doing this, you are inventing a rule without knowing why the rule is correct. Okay, so if you, of course, you need to be creative in the future if you want to do mathematics, to invent new rules, discover new rules, but correct rules, not wrong ones, yes? So, the reason people get confused, probably people are getting this impression. If I ask you what is the answer to this, what's the answer to this now? The answer to this is one power rule, you know. Do you remember a dot b to the power of n? We had a rule for this. It was a to the n multiplied by b to the n. But if you remember, I also emphasized there, because this rule is correct for multiplication, do not take it for granted that this is definitely true for other operations. No, that is true for only multiplication and division. But if I ask you what is the answer to this, how do you answer that? X squared times 9. But no one writes in this a little bit strange order. People write it 9x squared, yes? So the answer to this is indeed 9x squared and is correct. But because of this is correct, you mistakenly conclude this is also correct, that is your mistake. So please write it somewhere and just cross it over. But what is the correct answer? Can you help me to start finding the correct answer for this? Yes, I should expect you to be able to do that. Yes, I want you to write a correct formula for this one for me. Yes, Ali?
You can write another bracket with the same numbers because an exponent to the
An expression to the power of 2. Exactly. So this is playing the role of your box. If I tell you what is box squared, this means I take box, whatever is in, I multiply it by the same content. So now this expression is playing the role of that box here. So anything squared, a number squared, means that number multiplied by this, by the same number. And then let us try to do that. But then immediately this becomes an easy task for you if you just really learn what I told you so far. You just multiply them. So it becomes x squared. X times 3 is 3x. 3 times x is also 3x. But 3 times 3 is 9. And then let us continue. 3x and 3x. At this stage, no multiplication, addition or subtraction accordingly is involved. So it becomes x squared plus 6x plus 9. And you see that, you see x squared appears. 9 also appears. But if you just write this, this is not complete. There is an extra term which is plus 6x that if you write it in this way, you are just ignoring that. So be careful. You have to do it in the right way. Is that understandable? Okay, so let me give you one of these problems, and I want to wait for you to solve it for me. Yeah, it is recording. So x plus 1, this time I want you to do it for me to power 3. You have questions, Rasmus?
Shouldn't next person go to
Yes, sorry. Yeah, please go. And don't forget to go to the nurse after your friend comes back. Yeah, let me make this one x as well. So did you notice I changed this one from z to x? Okay, so let me, if you don't mind, let me just teach you how you can check your answers using GeoGebra, and then we can, of course, go back and start solving those problems. So if you open GeoGebra, you usually, by default, you get this. But what I want you to do, go to this CAS view, okay? And then it's better to get rid of what you really don't need. Of course, if you simultaneously want to draw graphs and things like that, it's good to keep them both. But I will go here and just shut the other one off. So I go to these views. And then, of course, I will try to get rid of these graphics. And I will take just CAS view. It's easier to, if you want to do this stuff, it's easier. So then what you need to do, for example, you go here and type expand in English, so that's probably the good word. I don't know if, no, I missed the spell. Expand. Okay, so you see that there are some options available for you. So don't get confused, just this one will work. So expand, we do not have other options, so you just click on that. And then you need to type in your actually expression. So for example, I think the first question was simple enough, so let us check it using GeoGebra. So what I need to do is just typing it in, so that it becomes x plus 1, and then I have a power of 3. Of course, if I use GeoGebra 6, might be it's easier for you. So I just go there and that's 3. That's just the normal lesson, and then I come back again. So, and then you press enter. So this is the finalized form of your answer. Please go back and check the first one. It is x plus 1 to the power of 3. If you got this answer at the end, before simplification, no, after being completely simplified, this should be your answer. X to the 3 plus 3x squared plus 3x plus 1. Yes? How many of you got this right? Okay. Now the point is that if you didn't completely and 100% find this right, then you need to take lessons from your mistakes. This is not something that a teacher can teach you. I can just draw your attention to this so that you be aware of your mistakes and try not to repeat them. Okay? So let me test another one, and then of course this is not important. I just wanted to teach you how to use GeoGebra step by step through our journey of mathematics. But let me just do the other one. Let me see if GeoGebra is capable of also expanding expressions without, just this is here one single variable. But the next example, let me just try to punch it in. So expand again, and then I choose the expand expression here. So what I have written, it's a little bit, I don't know if GeoGebra understands this syntax as well. So that's a squared, a to the power of 2. Then you go down, and then that's plus b. Yes? Oh, sorry. This shouldn't be here. This should be here, plus b. I am not familiar with Swedish keyboard that much. And then I have another pair of brackets, c to the power of 2. And then you go down minus, I don't know why it goes outside brackets, minus, where is minus? Minus d, and then I have another pair of brackets, 5 minus, minus 2e. I don't know if GeoGebra, because, yeah, usually expand is related to one variable. They should ask you which variable you want to do. So let us check. Yes, it was capable of that. But you need to be careful here. Might be your answer is different in order of terms. That doesn't mean it is wrong, okay? This is not necessarily the unique way of doing that. But I know how GeoGebra thinks. Can you feel that? Can you see the pattern? Why GeoGebra answered in this particular way? Might be this is not your exact answer, but please check. How many terms are involved? 1, 2, 3, 4, 5, 6, 7, 8 terms. You should get exactly 8 terms with the same combinations. The only difference, possible difference, is that you have different orders of terms. but they should read exactly the same, including the sign and the exponents. They have to be identical. But for example, if you have got minus 2c squared a squared e for the first term, that's also correct. If you have written 5a squared c squared first and the other one second, that's also okay. But you need to be careful, that's exactly the same. The reason do you see why GeoGebra provided you this answer? This is usually, you see here, let me just teach you here. This is, you see, it's a standard form. A standard form of an algebraic expression of a polynomial like that is to write terms in descending order of exponents. So GeoGebra usually uses the standard version. So you see here, x to the power of 3. 3 is the highest power in this case. So GeoGebra has written it first. It's not an obligation. If you write it the other way around in the exam, that's okay. But I want you to be organized. You can also be organized. And then you see that 3x squared, x is the highest power after 3, x to the power of 1, and then 1. Why do you think GeoGebra has written it here in this form? Because GeoGebra is probably also respecting the alphabetic order. So it is written in a standard form, but with respect to a variable, probably. Yes. So you see that the highest powers of a appear first. You see, a squared, a squared, a squared, a squared. All the terms involving a squared, which is the highest power for a, is appearing first. Okay, might be there are some I don't know, some algorithms there that they have to write in this way. Okay, why this is actually doing this. Okay. So I don't know how many of you got this right. Exactly. Okay. Yeah. So that's very good. So if you can do this, in principle, you don't have any problems. Even I myself might make mistakes when I'm doing calculations. It doesn't mean that I don't understand. So if you could solve this without any problems, it means that you actually understood the problem perfectly fine. Okay, so I don't think that I want to. So do you need another syntax today? Expand, so you can just test all your answers with GeoGebra, with the syntax of expand. Yes. So that's good to know about. But of course, the problem is. So I don't know. Do you want me to check another one? So which one was harder for you? Might be 4. Yes. Let us check also GeoGebra for this. So I would write again expand, but unfortunately I cannot simultaneously use the whiteboard and this one. So number 4, you said I have x here, then I have a pair of brackets, then I have x minus 7. If I want to write division, a fraction, I use this symbol division, it automatically goes down, and then 4, and then I have to come in front and finished, I go outside the pair of brackets, another pair, yes, sorry, and then I have 4x to the power of 2. Let me use this, and then I don't know why it goes outside. So okay, that's my mistake. And then I have minus x, and then you have plus 1. Am I right? So this is the. Hopefully you have the answer. Yes, very simple. Yes. So this is the answer that you're supposed to get. 4x to the 4 minus 8x cubed, 11 over 4x squared minus 7 over 4x. Yes? How many of you got this right? Oh, very good, very good. Because that's complicated actually. Yes. Very good. So let me also test this one, and we can take a photo so that when I solve that, we also check that my answers again. Yes. So let me punch the other one as well, the last one. How many of you think that you got this one right? So expand. So we go to a pair of brackets, x to the power of 3, and then minus 1. And then here, x to the power of 2 minus 25. So be careful that I am typing everything right. Thank you for help. And then you have another pair of brackets, but with a power. This is probably very lengthy for you. If you can do this one, then you really don't have any problems here. This one. Did I type it right? X to the power of 3 minus 1, x squared minus 25, and x plus 1 squared. Okay, ready for the answer now? So that should be your final answer. So you see, it's really, really powerful if you know how to use GeoGebra in an effective way to teach yourself. So you see, you can randomly write polynomials, make examples yourself, multiply them, and check them your answers against the answer in the GeoGebra. So if you don't mind, let me take a photo from these answers so that we can actually check our answers without having to. Yes. Okay, any questions regarding GeoGebra? Because I want to turn it off and start solving the problems, and then we are done. Any questions? So, yes, that feature is really nice. By the way, before leaving GeoGebra, now that this is open, let me also introduce you with this Wolfram Alpha. This is for free, most of it. So this is probably also very good to know about. So this gives you a lot of information. So here, there is a language in mathematics. It's called Wolfram language. It's like Python, for example. But this is not close to the machine language. So it has a lot of options. But this one is the free version. So you can do a lot of things. So for example, if I just write pi and then press, it tries to give you all probably relevant informations regarding pi. Okay, so for example, you see input is pi, so the machine learn what you mean. This is actually AI somehow, because I just type pi as I think, then the system realize what I mean probably. So this is showing the input to me. Is this really what you mean? I would say yes. And then you see that you have some decimal points here. Then you get some this information. So pi is a transcendental number, so it means that it cannot be a solution to any polynomial equation with integer fractions, integer coefficients. And then I don't know even what are they, continued fractions. So pi means 1 is equal to 180 degrees. There is a sum which gives you pi. See, it gives you a lot information about this. I really want you to also, by the way, there is a very nice one. If you pay a little bit of money, it gives you the solutions for your problems. Unlock step-by-step solutions, yes? And I have actually tested that because I have this at home. Okay. So that's also good to know. Remember this name. Yeah, just try to Google around to see that this guy is actually trying to put calculation on a different level. Okay, so they are working very hard for these cases. Okay, so that is good to know. Now let me just turn off this and try to see if we can indeed. Let us start from the last one, which becomes a little bit complicated, and number 4. I don't think you will really face other problems with that one if you do not if we don't get time. Okay, so let me just turn on the line. So now let us go back and to see that if we really get the answers right. If you don't mind, let us start from the very last one. So number 5, what is the first step to do? You see, I have multiplication of 3. I have the multiplication of 3 algebraic expressions, but one of them is a power of 2, so it means that essentially I am facing 4. Yes? So I don't know. Even if you need to discover it yourself. If I give you 4 numbers, and I ask you to multiply, you can group them in any way that you like to. Yes, you can multiply 2 by 3, you can multiply 4 by 5, 6, 20, and then multiply them 120. Or I don't know, you can multiply in any way that you like. For example, if I really want to multiply, I prefer to multiply this by that and multiply this by that. Why? Because 2 times 5 is 10, and multiplying numbers by 10 is easier for me. So that's what you need to understand. So here, I don't know which method you have used, but for example, number 5, if I want to write it down, because it is tedious, and I know that eventually I have to multiply them, instead of just copy and pasting everything from scratch again to lose time, I will start multiplying them, but I know that I have to write this twice, yes, to save some time for myself. So I multiply this by that. So what is the answer? X to the 5. X3 times minus 25 is minus 25 x to the power of 3. Please try to catch my mistakes if I do something wrong. Minus x squared and plus 25. So is there any questions so far? Okay, am I right? Hopefully. So let us double check. Usually, if you are doubtful, please double check in the beginning. Otherwise, it would be a mess to go solve everything from scratch again. So x to the 5 minus 25x cubed minus x squared plus 25. Is that understandable? That should be positive 25, not negative. Yes?
Yes.
Okay. And now, here, at least, I can write it next to each other. X plus 1, x plus 1. Okay, the first thing that comes to mind, is it possible to simplify this more? Unfortunately not, because none of the terms are similar. Yes? So what I have to do, I have to copy and paste the whole expression. And then concentrate on solving this piece. So I multiply this, it becomes x squared. X times 1 is x. 1 times x is again x. 1 times 1 is 1. Can I simplify this one more? Yes, because at this level multiplication is finished, addition is the case. So it becomes 2x. So of course you shouldn't be lazy. You have to copy and paste the part that you are not touching. Of course, in the exam I am talking. If you want to do it quickly, it doesn't matter. You can just write something, the answer below it, and start multiplying. But yeah, in exam you need to write the details for it. Okay, and then how many terms will be involved? 1, 2, 3, 4. 1, 2, 3. If you multiply them, it should be 12 terms involved. It's not that big, yes? So I just try to do that. X to the 5 times that one is x7 plus 2x to the 6 plus x to the 5. And then I multiply this by that. It becomes minus 25 x to the 5 minus 50 x to the 4 minus 25 x to the 3. And then when this is finished, I go to the next one, minus x to the 4 minus 2x cubed minus x squared. And then I go to the 25, so it becomes 25x squared plus 50x and plus 25. Okay. Is that understandable or should I repeat? Yes. I think that every one of you, I'm sure you understand, but it might happen that you make some mistakes. Even let me check it. It doesn't hurt. So I multiply this by that, x7, 2x6, x5, that's correct. And then I go here, multiply minus 25, x to the power of 5, minus 50, x to the power of 4, minus 25, x to the power of 3, that's right. And I multiply that, minus x4, minus 2x cubed, minus x squared, that's also right. And then that one's also right. But that's not finished. I have to check the similar terms. So what are the similar terms? X to the power of 7 is alone, agree? The less than, if I want to write it in a standard form, it is not compulsory to write a standard form, it's not in the book, but it doesn't hurt if you want to be organized. So 2 to the power of 6 is also alone. Yeah, so let me just, don't write them. So let me copy and paste, bring them down. X to the power of 7, 2x to the power of 6. But x to the power of 5 is no longer alone. So what's the answer now? Be careful. Now I am at the level of addition or subtraction. Multiplication is completely finished. So what would be the answer? Everyone, just say it. Please tell me the sign as well. Minus 24 x to the power of 5. Okay, are there x to the power of 4 terms involved? Yes. One of them here, one of them there. Okay, this is a little bit more tricky. If you say I will feel relieved actually. So what's the answer?
51.
Minus,
Minus
thank
51.
you. Everyone understand. Minus 51 x to the power of 4. And then we go to the next term. Is there anything more? I don't see. So these are the two terms. Can you tell me this one as well? Minus 27 x to the power of 3. Yes? And then let me take this one, I don't know. This one with that one. Are these the only ones? Yes. So what's the answer? Positive or negative?
Plus
Plus
24x to the power of
2. Thank you. And then, is there anything left? 50x is left, but I think it is alone. Do you agree? 25, the constant term, is also alone. So this becomes 50x plus 25. So that would be the answer. I had the photo here, so let me just see that if I haven't made any mistakes myself. Where is that? So I read it from here. You can check it there. X to the 7, 2x to the 6, minus 20. So okay. Minus 24x5, minus 51x4, minus 27x cubed, plus 24x squared, plus 50x plus 25. So that's correct. So what we get is this one. Any questions? But the most tricky one, because you might be a little bit weak in actually acting with fractions immediately, might be this one. So let me also do this one together. Any questions regarding this? Okay. So let me, I want to clean somewhere for you. So I don't know, I think if I solve this one, let me start here. So tell me your strategy. How do you want to solve this? So how many operations do I have here? I have a one multiplication here and one multiplication here. So I am facing three expressions. One of them is a very simple one. The other ones are these two. So I multiply this one into the first one, and when I get the answer, I multiply the answer to the third one. That's the same strategy. So what can I do? I multiply x by x, so it becomes x squared. So this is number 4. Then I get minus 7 over 4 times x. And then I copy and paste. This is a have to, by the way. Don't be in a hurry. Because when you write equality, you need to respect the meaning of equality. So you have to copy and paste even those parts that you haven't done anything with them. And then I have to start multiplying it again. So it becomes 4x to the 4 minus x to the 3 plus x squared. Any questions here? I just took this one, multiplied this here, here, and there. Okay, this is what I want you to do. If I multiply this by that, how do you do it in your head? Many students, I think you multiply 4 by 7 and then divide by 4. Don't do that, even though that's totally correct. I want you to change the habit of thinking. When I want to multiply 7 over 4 by 4, these numbers are so small, it doesn't make that big difference. But if you do not change the way that you think, it would be problematic for you for harder lessons. I always simplify these two. I do not multiply them. So the answer would be 7. But of course the sign is negative. Okay, can you tell me what can I write at the end here? Minus or positive first? Minus. What is the coefficient? 7. And what is the literal part? X?
X power to the power of 2 squared.
No. I am multiplying this by that. It becomes x to the power of 3. The next term will be positive 7 over 4 times that one, that is just 7 over 4. X times x is x squared. And then minus 7 over 4x times that one is just very simple. Is that understandable? Yes or no? Okay. But I can simplify now. Let us write it in a standard form, even though it is not compulsory here. So, this one is alone. So let me just do not underline that. 4x to the 4 is just a single term. And then let me go to the cubic terms. There are 2 cubic terms with powers of 3. Can you do it in your head now? Don't forget, multiplication is finished. Minus 8, thank you. Minus 8, x to the power of 6 or 3? 3, yes. And are there similar terms involved again? Yes, here and there. Can you do it in your head without going to scratch paper? 11 over 4. Why? Because the coefficient here is 7 over 4. The coefficient here is how much? 1. And I am supposed to add them. But this is easy to have it in mind, 4 over 4. So if you add them, it becomes 11 over 4. So the answer is 11 over 4, x to the power of 2. And finally, that one is just alone. And that would be your polynomial. I think we did it right, didn't we? So just check it. 4x to the 4 minus 8x to the 3 plus 11 over 4x squared minus 7 4 over x. Yes. Let me just try to test your understanding a little bit. If I ask you what is the constant term in this product, you see, I did this product. Okay, I did this product, and I asked you what is the constant term. Now you have the solution in front of your eyes. Can you answer that question? What is the constant term in the expansion of this expression? Just read it from this. Constant term means the one without any letter part. That's just 25, yes? You see there are some letters involved in all of them except the last one without any excess. That is called the constant term. The constant term is 25. Okay? But let us test your understanding. Could I anticipate the constant term will turn out to be 25 without even starting multiplication? So my question is that do not start multiplication at all, but tell me how could you predict that the constant term finally turns out to be 25? Yes, please.
Because the only other terms that don't have x in them
Yes?
are negative 1 and 1.
Yes?
And since it's negative 25,
Yes?
if you multiply negative 1 by negative 25, it'll be just positive 25. And if you multiply that by 1, it's just 25.
Yeah, great. Thank you very much. So what you are saying is that because I want to get 25, so it means that I shouldn't multiply any x's involved. So it means that if I want to get something without x at the end, I need to see how many opportunities are here. So if I want to get something, which is not constant, which is constant, there is only one possible way for me to do it. Take this term, multiplied by that term, multiplied by that term, multiplied by that term. That is the only way that I get a term without x involved. And that's what you explained very good. So minus 1 times minus 25 is positive 25. Positive 25 times 1 is 25. 25 times 1 is again 25. So it was predictable that the answer would be 25. So what is the constant term here? What is the constant term here? None. So the constant term is 0. The constant term is 0. Was it predictable for you here? Because if I ask you what is the constant term here, can you guess without this? What is the constant term after multiplying this? According to what was your name?
Elijah.
Okay. May you repeat it again?
My name?
Yes?
Elijah.
Elijah. So, could you follow Elijah's reason to say what would be the constant? I am just hiding this, covering it. Just this one. What would be the constant term? Yes? Minus 7 over 4. Yes? Because I have a minus 7 over 4 here and 1 here. But do you think any constant term will remain if I multiply this one here? Of course, it is clear that I had one single constant term coming out from here, and when I multiply x by it, I will never get any constant term. Yes? Instead of the constant term, which was minus 7 over 4, now it is clear I get minus 7 over 4 multiplied by x. Okay, now there is also a trick I want to teach you. If you want to find the constant term, you just put 0 instead of x. That is the same thing. If I put 0 instead of x, I get the constant term. But a little bit harder question. I want to see how much you understand. Okay? If I ask you, what is the sum? What is the sum of constant? What is the sum of the coefficients together with the constant term? So we can answer it here. Let us do it in our head. What is the coefficient here? 1. Add it to this one. 3. Minus 24 is minus 21. Minus 51 is minus 72. Minus 72 minus 99. Minus 99 and 24 is minus 75. Minus 75 minus 25 and 25. That's interesting. It's 0. Yes, it turns out to be 0. Yes, that's 0.
What?
Yes?
Was that a coincidence or?
No, that was a little surprise for me. But I could see this before even starting multiplication. That was a coincidence that this becomes 0. This is not always 0. But I could see before multiplication that this definitely becomes 0. How? I am talking about the sum of the coefficients. You see, I calculated it just by manually adding, subtracting. It turned out to be 0. But I didn't need, if my goal is just to find the sum, I didn't need to go through this long process. Immediately I could say that the answer is 0. I want you to detect to find the logic. Why is that? Let me guide you. If I ask you, put a number for x so that it gives you only the sum of the coefficients, which value you choose for x? No. If you choose 0, all of them are cancelled, only constant term is left. What you need to put? 1. Agree? If instead of x I put 1, what will happen? The first term, 1 to power 7 is just 1, the coefficient is 1. If I put x equal to 1, 1 to power 6 is 1, and times 2, it gives you 2. The next one gives you minus 24. The next one gives you minus 51. So you understand that. If I replace x with 1, what I get is the sum of the coefficients. Okay? But this expression is equal to this expression. So if I replace x with 1 there, whatever I get, if I do the same thing here, I should get the same answer. So now replace x with 1 everywhere. This becomes 2 to power 2. This becomes 1 minus 25, which is minus 24. But then this becomes what? 0. And if you multiply them, the answer is 0. So it was predictable for me that the answer is 0. Yes? So you can test. We have the Geogebra here. Can you predict what would be the sum of the coefficients here? Think about this and try to a little bit use Geogebra to improve your guess.
Wait, I don't.
So let me because I have this one in my memory. So let me just finish this lesson. If you go to Geogebra, if you go to your solution, the answer is this. Now, if I ask you what is the sum of the coefficients, what is the answer? The coefficient here is 1, plus 3, 4, plus 3, 7, plus 1, 8. Do you agree? The sum of the coefficients is 8. Now, replace x with 1. 1 plus 1 is 2. 2 to power 3 is 8. Yes, so that's the answer. So if you replace x variables with 1, you get a number. That number is the sum of the coefficients after expansion. And if you replace, always. No, but I want you to understand, not memorize. Did you understand it here? Because if I replace x with 1, what is left is the sum of the coefficients. But this expression is equal to that expression. If I replace x with 1 here, I get a number. If I replace x with 1 here, should get the same number because they are equal. So that's the number. So that is the logic behind that if you want to find just the sum of the variables. Thank you very much.